In order to explain what's platform engineering, I'm going to use this graphic that captures a few key events throughout history since 2003 that explain the evolution of software development practices and tools. Starting with site reliability engineering, this field emerged to address a problem or a perceived problem in its time, which was that applications become unreliable once handed over to IT infrastructure and operations team. Let's see how this was solved. Before the introduction of site reliability engineering, there were two types of teams inside organizations. The development team was developing applications, and once those applications were ready, they were handed over to an IT infrastructure and operations team that installed the applications on servers. The problem was that deploying those applications on servers was not a straightforward process. Problems came from a variety of issues, including incompatibilities between the operating systems on the servers versus the developer workstations, different library versions installed in both environments, as well as lack of understanding of the software by the IT infrastructure and operations team, which did not develop those applications. And it is that last point that site reliability engineering, introduced by Google in 2003, aims to address. Google thought that if we have software developers inside the IT infrastructure and operations team, or people with this type of background, it would help understand the applications and figure out why they're not working as well on the servers as they were on the developer workstations. Meanwhile, site reliability engineering did not address the root causes of the issues in production, which were the incompatibilities between the infrastructure, operating systems, and different dependencies to the applications between the developer workstation environments and the servers. Going back to the timeline, let's look at what happened after 2003, when the solution of augmenting the skills of the IT infrastructure and operations team to include software development skills was introduced by site reliability engineering. In 2004, a new tool named Jenkins was introduced. This tool aimed to increase software development velocity by automating the process of integrating new code and deploying it into production by using CI/CD pipelines. Soon after, in 2005, people were starting to talk about microservice architectures. Although microservices brought a lot of great benefits such as scalability and independent deployment of software components, they also brought complexities in terms of how software was developed and run in production. All of this development, combined with the fact that the root causes of unreliability remained to be solved, led to the emerging of a new field around 2007 called DevOps. This time, the problem that needed to be solved was pretty much the same problem but framed differently. The problem was that there is a disconnect and inconsistencies between development of software and operations. Given the evolving understanding of the problem since 2003, together with the appearance of new tools such as Jenkins that allowed continuous integration and continuous deployment, SRE had to make place for a shift in mindset, a new set of practices and tools that would address the problem of reliability of software in production differently, in a holistic manner, by providing a feedback loop from development teams to IT infrastructure and operations teams and back, addressing all of the stages of the software development lifecycle. Now it was clear what needed to be done in order to solve the problem of disconnect and inconsistencies between development and operations, integrate and automate the work of development and IT operations teams. Now what was left to do was for organizations to figure out the set of tools they wanted to use to achieve the benefits promised by DevOps. There was already Jenkins introduced in 2004, there was virtualization going on since the 1960s, allowing operating systems to run an infrastructure they were not intended for, but only recently becoming available to developers, so you can run server operating system on a developer's laptop. There were other tools that started emerging, such as Docker in 2011, allowing to containerize applications. There was Kubernetes, introduced by Google in 2014, allowing the orchestration of containers. There were a number of other DevOps tools launched by different cloud providers and independent software development companies, all the proliferation of DevOps tools, as well as the difference in terms of maturity level between teams of the same organizations, gave the rise of a new problem. It became hard to scale DevOps across multiple development teams within an organization. So platform engineering emerged in 2019 in order to bring a solution to solve the problem of scalability of DevOps. Apply a product mindset to DevOps tools to allow self-service and to improve discoverability. The idea was that DevOps tools should be treated as an internal development platform used by all of the teams, which centralizes tools, and it's created by dedicated platform engineering team. This provides the teams with standardized, secure, and scalable self-service capabilities. Today, platform engineering is considered so strategically important to organizations that by 2026, Gartner is predicting that 80% of large corporations will establish dedicated platform engineering practice teams. If you enjoyed watching this video, don't forget to like and subscribe so you can see more of this type of videos in the future.